Hello, welcome to this episode of the Derek Show. I'm going to talk about printing Lego using PETG filament and the Creality Spider all metal hot end on the Ender 5 Pro. I always like to play with Lego because it's a good benchmark test. That it's very difficult to print, as you can see. I tried printing first here under very high speed, or relatively high speed, like 80 millimeters per second, and you can see how it turned out. So next what I did was I looked at my printer and I did some troubleshooting by looking at the damaged plate that I printed. And one thing I think is that I don't want to change too much. So the first thing I did was I slowed the print speed. So as you can see here, the print speed is mostly 10 millimeters per second. And then next you'll show that for the first few layers, or the first 5 layers, I slowed it down even more. I set to 5 millimeters per second. Last thing I did, and you'll see the screen, is also turned off retraction. So with the slower speeds and retraction off, I now tried printing it again. And as you can see, it's slower, and if you look at the first few layers, it's very promising. Notice everything is sticking this time. And no supports, no glue on the bed. That's very important, just slower speed. And see how the quality has improved so much. So I'm very excited by this so far. Now look at this, even the overhangs with no supports is still very flat. There's no dipping, and the plate just pops off the bed when I'm done. So this is very good. And this print looks good. Now one factor in my successful printing recently that is different from before is that I used a nicer brand of filament called Erie one, as you can see here, and I'm not sure if that's the reason why I'm able to print the Lego now that's so in such good form. So I'm going to try another test. So like I said previously, the Erie one filament's more expensive, so I decided to switch to this generic filament that I got from this local 3D printing store, and I see the quality of the Lego that I can print with that. So I managed to get a video of the first few layers being print of this same Lego plate, and as you can see, the little circles are sticking to the print plate. I had trouble with that in the past, even if I put glue on it. Now there's no glue, it's just 85 degrees Celsius print bed temperature, and it's sticking. So it's looking very good, very promising. So as you can see now, it's printing the top of the plate, and I have to stress again, it's not using supports. So you can see it's looking very good. So now I'm done. As you can see, check out the top and bottom of the plate. They're very good, very firm. There's no printing errors, it seems. So I'm very optimistic, and I'm looking forward to. I'll show you how well it connects with real Lego and other printed Lego parts soon. So even though that plate print went well, I felt obliged to try and print it one more time just to prove that I can repeat it successfully over and over again. So as you can see, this plate also turned out very good, very well printed. All the support circles in the bottom and the studs on top. As you can see here, I also printed out a typical Lego brick. So if you look at it, it's very good quality. And this was printed right side up, no supports. So again, I just wanted to make sure I could repeat the process. So I printed that and checked out that Lego brick again. It still looks good. So now I'm going to take a short break and go through the all-important connectivity test. That is, trying to attach these Lego parts that I printed onto other printed Lego parts, as well as real, authentic Lego parts. And of course, those knockoff ones you can get from WeBrick, which is the most popular site. So as you can see, just go through and you can see it snaps on and holds together very well, right? And with PETG, it's firmer, it's not brittle like PLA, then it stays, it doesn't break. So this is very good. These Lego parts I printed are usable. So I'm very happy with that. So next I want to print a brick with a ball socket. And what I did was I did it so that the brick was upside down and I used supports because I was afraid that the arches at the socket point might dip if I print it without supports. So as you can see, it's a good quality brick, but it's a lot of trouble to clean up the supports afterwards. So rather than remove supports, I decided to try just printing the ball socket brick right side up, no supports, just like I did with the other parts, to see what would happen. So now that the print is done, you can see now I'm trying to move it and you can see that the quality is very good. And this is no supports, right? And right side up. And look, the arches of the ball socket, they're good. They're not dipping. So this is very good, very promising. Of course, now I'm doing the obligatory second print of the same ball socket right side up. No supports to make sure I can repeat this over and over again. So with the success I've had so far with the plates and the other prints, I decided to print a Lego ball joint. Right side up, no supports. So as you can plainly see, this brick ball joint came out really well, just like the others. Right side up, no supports. So this is very promising, and it seems to be very repeatable too. And of course, I felt much obliged to once again try the print again one more time to see if I can get that brick with ball joint printed in perfect order, right side up, no supports. So here we go again. Now as you see, this time I was quick enough. I managed to catch the beginning of the print when I was going. As you can see, those thin lines are coming out really well on the print bed, and same with that, the circle center to keep the brick stable. So it's looking very good, and I think a lot of it has to do with the Hotend, the Creality spider all metal Hotend, as well as my bed leveling. So I'm very happy with this. So now that we're done, once again we can see that we have proven to ourselves that we can repeat the same quality print over and over again. See, it looks very good. And I will test the connectivity of this part very soon. Now I'm just going to take a short break and talk about the situation where you cannot find the STL file of the Lego part you want to print online. Well, there's a very simple solution, and that is to basically pull the part from an existing Lego CAD tool. So my recommendation is to use the set of LDraw utilities because it's a complete set and it works, and I'll show you how. So first you have to download the LDraw utilities, and I'll provide the link in the description later. But it'll come with several utilities, the most important being LeoCAD and LDView. So as you can see here, I have LeoCAD open, and what you do is drag the part you want to print onto the screen using LeoCAD, and then export the file as an LDRAW format file. So the next step is basically take the LDRAW file you exported and load it into LDView, as you can see here. LDView is good because it has the capability to export as STL file, and when you do so, you'll present it with a menu where you can choose the scale, and it'll give you a choice: centimeters or millimeters. Choose millimeters. That is the scale that's compatible with the Lego parts out there. Okay, just like this. So then you can generate your STL file and save it to disk. So now that you have a good STL file, you can import it into your slicer. In this particular video, I use Ultimaker Cura because I'm used to it, right? So everything's in there already. So I just import into my slicer, make sure the settings are correct, like for print speed, 20 millimeters per second max. First layer, 10 millimeters per second for the first like 10 layers. No retraction, right? No supports, no rafts or any type of build plate adhesion stuff. And that should work. So now that I've sliced that L draw part, I put the G code file into my printer and start printing it. So this will be interesting, and we'll see if it comes out exactly like the Lego part should be. Now again with this print, I managed to video at the beginning steps, and as you can see, the bottom part, those bottom lines, right, is looking very good. It's sticking to the plate, perfect adhesion, no glue. Okay, this is just itself. So this is a very good sign. So now, as you can see from the final product here, it came out very good. And even the arches, like the overhangs, they're not dropping or anything like that. It came out very solid. So this is very promising, a very good sign. Now I also printed out a double inverted wedge, as you can see here, because it has the two overhangs again, and it also came out very well. Right side up, no supports, and look at it. It's very firm, very solid. I'm very happy, and the results are very promising. Okay, so now for some connectivity testing. First, I'm going to start with a very simple brick, and as you can see, it does have some issues connecting to the regular Lego or knockoff Lego parts from the top. Again, another connectivity test, but this time I used another set of bricks, this time with the inverted wedge and the double inverted slope. And as you can see, this is much better, much more promising. It connects perfectly with regular Lego as well as knockoff Lego that you can get from WeBrick. So this is playable Lego part, these prints. By the way, I just want to mention that as we go along, I did a previous episode on printing Lego using PETG, but that was with the Micro Swiss Hotend. And with that one, I also used a 0.2 millimeter nozzle. Now for this, I just used the basic 0.4 millimeter nozzle, and everything was okay. But you have a different hotend. I used the Creality Spider all metal hotend. So that was I think what made your difference. But the regular nozzle 0.4 millimeters works fine. So for the last connectivity test of this episode, I used the bricks with the ball socket and the ball joint because in addition to the regular stud connections, you also want to try out the ball joints, I mean. As you can see, it works very well. It's very playable. So even you can put the ball joint into the ball socket and you can have their moving part so you can use to make like Lego formers or other type of mechs or robots. So it's very promising and the Lego parts generally are playable. Um, that first simple Lego part, I don't know why it's the top part doesn't connect to the bottom of something else, but I think it just a few more attempts should do the trick. If I find something special, a certain setting in the slicer, I'll post an episode on it on my YouTube channel here. So thanks very much, and I guess got to say that based on my experimentation, I think the biggest factor in the successful printing of Lego parts was the Creality Spider all metal Hotend. I think that made the biggest difference. Yeah, I turned off retraction, but I don't think that was a huge. I don't see that as having that such a big impact. I think it's the Spider Hotend for some reason has got some good new technology in it that helps with printing Lego parts. Yeah. So thanks very much for watching the Derek show. I'll put on the details about slicer settings, where to find STL files of Lego parts, the thing of LD, where to download LD draw utilities, etc. in the description of this video. Okay, so don't worry. So thanks again for watching the Derek show, and I hope to see you again. Bye.